Fine. So let's start this MPLS now, which is stand for multi-protocol label switching. Right? We have to study that. We have to go through this MPLS now. Do you remember traditional routing? If you talk about traditional routing, it is like this: R1, R2, R3. What happens, for an example, let's say one packet came in onto this interface of our router 1. What is the first step performed by a router? It checks destination MAC address. If it matches, we'll accept it. Then we'll open its IP header. Accordingly, it has to perform lookup in its FIB, because SAF is by default enabled, and if SAF is not there, then definitely it has to perform lookup in its routing table. But this time, in this example, we are assuming that SAF is by default enabled. If SAF is enabled, then definitely routers will form FIB, forwarding information base. So whenever a device will receive any packet, it will open its IP header and will perform lookup in its FIB. Got it? Fine. And then if it is having destination prefix available in its FIB, then it will be, it will route your packet accordingly. It will switch your packet accordingly, right? According to the entry available in your router's FIB. Fine. It will look at the exit interface as well as next hop address, and accordingly it will switch your packet. And this process will happen for each and every received packet. It's not it. Means that routers will open IP header of all received packet. It's mandatory, it's compulsory to open IP header of each received packet. Now think about that situation in which you do not have destination prefix available in FIB. Will it be possible for a router to switch that packet? No. Means if we are saying that that prefix is not available in its FIB, it means it is also not available in RIB, because in FIB only those prefixes will be available which are available in RIB. RIB. You understand? So of course those prefixes will also not available in RIB as well. So whenever a router, whenever a device will receive any packet of, let's say it have received any packet and the destination IP of that packet is not available or is not present in the FIB as well as RIB of the router. So what will happen then? It will simply drop that packet. So now thing is like your routers must have all prefixes information in their routing table, and then all routers has to open IP header, which is 20 bytes long header, As you know, the default length of IP header is what? 20 bytes. Means that every router has to open 20 bytes long information, and then it has to take decision accordingly, and then it will transmit your packet accordingly, after performing lookup in its FIB or RIB, whatever it is, right? Definitely this process is slowing down your performance. Of course this process will slow down your network performance. You know why? Like whenever a router will receive, see, it will be happen on each and every router, right? Whenever a packet will be delivered onto any router, first of all it will open its IP header, and then of course it has to perform lookup in its FIB. Understand? If it is happening, then you understand very well. Like of course there will be some more delay, right? it will, I mean, there will be some more delay, and of course CPU utilization will be higher because CPU has to open 20 bytes long information, and again it has to make some necessary changes, like it has to make changes inside TTL value, then header checksum as well, inside TTL value of the IP header as well as header checksum, and then it will switch your data, right? So of course it will take some time over there to complete this process. Fine. To solve all these issues, tag switching came into the picture. Tag switching, which was proposed by Cisco itself. Tag switching. Do you remember frame relay? In frame relay, like frame relay switch was always switching your packet, your data based on their DLCI numbers. It's not it, because frame relay switch do not understand anything else apart from DLCIs. You understand? So basically frame relay switch was switching your data based on DLC numbers. And DLC number was, I mean, what is the meaning by DLC number? It's a kind of tag. It's a kind of tag. So frame relay switch also performs kind of tag switching. But frame relay was completely a layer 2 technology. And also there can be multiple problems, right? I mean, because of it was only and only layer 2 technology, right? But MPLS is not a layer 2 technology. It works in between layer 2 and layer 3. You understand? Tag switching is not a layer 2 technology. It works in between layer 2 and layer 3. So basically now in tag switching, or you can also call it MPLS now, because nowadays we are calling it as MPLS, multi-protocol label switching. In MPLS what happens actually, that in between layer 2 header and layer 3 there will be MPLS tag. There will be MPLS tag will be added in between layer 2 and layer 3 headers, and this MPLS tag will be just 4 bytes long tag. You understand? 4 bytes long, same as .1q tag. Do you remember? .1q tag was also adding only 4 bytes, right? I mean, that tag was also 4 bytes long tag. But here in MPLS, remember, it is always, I mean, it is also possible to add more than one tag in between layer 2 and layer 3 header. But this time just try to get it like there will be one tag in between layer 2 and layer 3. And this tag basically is a number, will be allocated by MPLS to your packet. Like these numbers can be in between 16 to, and now I think it is 100,000 and something, because it is here to represent your tag number we will be using 20 bits. So to exponent 20 you can define that range. From 0 to 15 it is reserved, but from 16 to 100,000 or more than 100,000 it is something like that, right? Because you are having 2 raised to the power 20, so you can calculate that. To raised to the power 20. Right? So now thing is, like, whenever a router will receive a packet, so after layer 2 it will find, tell me, it will find tag. So this time routers, I mean in a MPLS domain, routers will not require to open your IP header, which is 20 bytes long, and routers can switch this packet based on its label only. Now you will get confused that how is it going to be possible? Like how will it be possible for routers to switch your data based on their labels? I mean, this is also known as label. Tag or label is kind of same thing, right? So basically in MPLS, the most advantage, or you can say the biggest advantage of enabling MPLS in your core, in your network, is that routers will not require to open IP header anymore. Now routers can switch your packet, your data, based on their label numbers, based on their labels, or based on, you can say, tag values. So they will not require to open your IP header. And if it is not opening 20 bytes long IP header, it means your overall performance of devices will be higher, will become higher, or it will be improved, is not it? Because now your routers will not require to open that IP header to switch this packet. If you are remembered, in BGP, what I did, I configured indirect neighborship in between R1 and R4. So there was a black hole. At that moment, I told you, if you remember, that here to solve this problem, you are having GRE tunnel, right?
Yeah.
Or apart from GRE tunnel, I also told you that if you are running MPLS, then also you will not require to, then even you will not require to configure GRE tunnel. And these routers, like R2 and R3 will not be having those prefixes in their routing table, but still with the help of MPLS, they can switch your data. So basically this R2 and R3 will start to switch your data based on labels. Based on labels, if MPLS is running, so that these routers will not open their IP header, and if they do not open their IP header, they will never come to know that they do not have destination prefix available in their routing table, because they will not open that IP header. They will switch that data based on their labels. That is why it will not be necessary to enable, to have those prefixes available in the routing table of R2 as well as R3. That is why we always say that if someone asks you that, okay, why should we prefer to use MPLS in our network? So you would simply tell that MPLS, the very first thing, it will improve your packet switching performance. Very first thing. Second, after implementation of MPLS, now your core can become BGP free core. Your core can become BGP free core. You will not require to run BGP on all routers, on all core routers, right? Just configure BGP only on edge routers. With the help of MPLS, routers can switch your packet even if they do not have destination prefix available in their routing table. MPLS is an open standard. It can carry any type of data, whether it is layer 2 or layer 3. It can encapsulate layer 2 data as well as layer 3. That is why in MPLS it is also possible to configure layer 2 VPN as well. Here you can also configure .1Q tunnel. I'll let you know that what is the uses of that, right? But in MPLS you can also configure layer 2 tunnel, because it supports all types of data. That is why its name is MP, multi-protocol. And then further it can support IPv4, IPv6 or whatever it is, right? But remember, after enabling MPLS onto routers, now routers will be responsible to switch your data based on their label number. Now the question is that how will it perform all these things? But I hope that you have understood now why MPLS is going to be very crucial for us, because all these things will be really important in terms of internet service provider. Fine, guys. So basically this is this is all about the basic definition of MPLS, right? So second thing about this MPLS is like if we talk about this MPLS, then we are having some terminologies over here like LSR, H, LSR. This LSR is also known as P router. HLSR is also known as PE router. P means provider. P means provider edge. Right? Like for an example, this is R1, R2, R3, and this is customer A, customer B, and this is your service provider. Actually, these three routers are placed at the end of service provider. So basically, let's say that here MPLS is running. So this is edge router by which your non-MPLS domain is connected, right? Because customer will not configure MPLS at their own end, right? So a router which is connected with the non-MPLS domain is known as actually edge LSR, label switch router. LSR is what? Label switch router, and it will be completely LSR, a router which is having its all interfaces in MPLS domain only, right? Will be known as LSR. Then it will also known as LSR because R3 is also connected with the non-MPLS domain as well as MPLS domain, right? So a router which is connected with the MPLS domain as well as non-MPLS domain will be known as LSR. A router which is having its all interfaces available in MPLS domain only, it will be known as LSR. A router which is having again, some interfaces in MPLS domain and some interfaces in non-MPLS domain, it will be known as edge LSR. You can also call them like P router, and it will be known as now provider edge, and it will be also provider edge. Provider edge router is that router which is also connected with the customer. Understood? Now, I have already taught you meaning of fib. I have taught you that how routers, how network devices forms fib, forwarding information base, and like I have already taught you SAP. Remember, SAP, Cisco Express Forwarding, is mandatory for MPLS. It's mandatory, right? So apart from it, we are also having some other terminologies over here like LIB and LFIB. LIB is same as RIB. Like RIB is always stored in control plane. In same manner in MPLS, LIB, label information base. Label information base will be there in control plane, and then it will get copied back into LFIB. LFIB is what? Label forwarding information base, and LFIB is same as FIB, and it will be inside data plane, whereas LIB is same as RIB, and RIB is also part of control plane. So RIB, LIB, RIB, LIB, FIB, LFIB. You understand? Hello. LIB is what? Label information base would be stored in control plane of the device. LFIB is label forwarding information base will be stored in data plane of your device. In LFIB, it will be having combination of prefix as well as its label. Whereas, as you know that if you talk about the fib contains only prefix information. But once you have enabled MPLS, and then after, if that prefix is having any label, then definitely you can also see that label in fib as well. But here there are certain rules for MPLS domain, that if you receive unlabeled packet which is coming from customer, right? Of course, from customer you will receive, service provider will receive unlabeled packet. So if MPLS router receives an unlabeled packet, then it will always perform lookup in its. This is our green rule of MPLS, that if you receive unlabeled packet, if you receives any unlabeled packet, then it will perform lookup in its FIB always. If your router receives a labeled packet, means a label is allocated to your packet, right? So if your router is receiving any labeled packet, then lookup will always be performed inside LFIB, label forwarding information base. Understood? If you are receiving labeled packet, if your router receives a labeled packet, then it will always perform lookup in its LFIB. If your router receives unlabeled packet, then it will always perform lookup in its fib. Is there any problem? Sure. LFIB same as FIB. The only thing, the only difference in between FIB and LFIB is, like in fib you are having, previously you were having only prefix information, whereas in LFIB you will be having the combination of label and prefix both. LIB same as RIB, only label information, right? Fine. Now, after going through these basics of MPLS, let me open the book of MPLS now. See, foundations of traditional IP routing. Routing protocols are used to distribute those prefix information, right? Hello, layer 3 routing information. We were using RIP, IGRP or OSPF to exchange prefix information. Here, of course, we will also require to exchange label information between two routers, right? So for that purpose, we will be having some distribution protocol, label distribution protocol, which is LDP itself. Or Cisco proposed TDP first, tag distribution protocol, before than LDP, right? Label distribution protocol. So same as like we are having routing protocols, in same manner we will also be having label distribution protocol, which is LDP itself, label distribution protocol, right? So forget about that. But you see that if you talk about the traditional IP routing, then routing would be performed by routing protocols dynamically, and forwarding decision is made based on packet header and local routing table. Routing lookups are independently performed at every hop. What I said to you, this is traditional IP routing. This is update, then packet see, updates are going from this R1 to R2, then R2 to R3. Then one packet came on R3, which wants to reach 10.1.1. It performed routing lookup, then it gave it to this router, again it performed routing lookup, then finally it gave it to R1. right? Finally packet have reached R1. So every router may need full internet routing information. Destination based routing lookup is needed on every hop, because of course routers will always perform lookup only for their destination IP. Basic MPLS feature. MPLS resides in between both IP routing and SAP switching. As I said, it works in between IP routing and SAP switching. MPLS is a forwarding mechanism in which packets are forwarded based on labels. MPLS was designed to support multiple layer 3. What I said. Typically, MPLS corresponds to destination network equivalent to traditional IP routing. Of course, labels will always correspond to destination networks only. And this is the only thing which we are required to have actually, or which will be required for routers. Like they must be having information about their destination networks. So basically, here also in MPLS, here in MPLS labels itself will correspond to your destination networks only. Means that whenever they will perform lookup inside LFIP, they will never look at the source label. There is no source label. Label would be generated only for destination prefix over here. Label will never be generated for source prefix, because whenever a router performs lookup in its routing table, it does not look at its source IP address. It looks at destination IP address only. Now you see, MPLS is designed to, okay fine. SAP switching will be discussed in detail as I have already discussed it with you, but remember SAP is mandatory for MPLS. Benefits of MPLS, you see, you can perform unicast routing. It can also support multicast IP routing. You can configure VPN over here, virtual private networks. You can configure TE, traffic engineering, quality of service, any transport over MPLS as well, ATOM. Any transport over MPLS. Any transport over MPLS means layer 2 VPN. Right? So these are the advantages of MPLS. Now you can ask me that what is the uses of VPN? I'll be discussing it with you, but here our main focus will be only on VPN. Our focus will be only on VPN. This is the most important topic of MPLS for us in CCIE routing and switching. But in terms of service provider, then definitely this traffic engineering will also take place, but traffic engineering is not part of routing and switching. See, MPLS decreases forwarding overhead on, because now core routers will require to switch their data based on labels. MPLS can support forwarding of non-IP protocols as well. As I said that it also supports layer 2 VPNs. Like it can carry your STP based traffic which is not an IP based packet, VTP based packet which is not IP based packet, but it can support them as well. As you know, control plane and data plane, as I said, LIB, label information base, will be in control plane, whereas LFIB will be in data plane. Right? So LFIB will be combination of RIB as well as label exchange protocol. With the combination of that, it will form LFIB. LFIB, fine. I hope that you have understood the difference in between LIB and LFIB. LIB will form in control plane, whereas LFIB will be formed in data plane. LFIB is same as like FIB, whereas LIB is same as RIB. In this work, see, this is MPLS LSRs, label switch router. See, as LSR, because it is also connected with non-MPLS domains. See, this is shaded. This is shaded, right? This shaded network is MPLS domain. So it means after this router R1, we do not have any MPLS domain anymore. Then after R3 also, we do not have any MPLS domain. That is why these two routers R1 and R3 have been configured, have become actually as LSR. Whereas this router is working as a LSR. LSR forwards labeled packet in the MPLS as LSR forward labeled packet in the MPLS domain, and it forwards IP packet into and out of the. So a router which is receiving packet from non-MPLS domain or which is forwarding packets towards non-MPLS domain will known as edge LSR. They are also known as like P and PE router. In a service provider MPLS environment, and as LSR is typically known as a P router, PE, and LSR is known as a P router. Now let's talk about that how does it really work. I mean, how will it be possible for routers to switch your data based on labels? Let's say this is R1, you understand, and this is what? This is R3, and let's say this is what? R4. S0 by 0, S0 by 0, S0 by 1. Fine. I'm just trying to give you an example, right? Here I'm just giving you an example. So now this network is directly connected to R1. Let's say that you have configured MPLS in between these four routers. Understood? I'll let you know now that how MPLS really works actually. Now, if you have enabled MPLS, then R1 will also generate one label number for it. Let's say it have generated label number, tell me, 10.
0 to 59.
Wait. Let's assume it's 10. Now R1 will advertise this information to R2. That if he wants to reach, try to understand, if he wants to reach 10.1.0, then your label is going to be 10. I mean R1 will inform to R2, right? So for R2, of course it will receive this 10.1.1.0/24 via, tell me, via 12.1.1. this will be next hop, right? And now because it received a label number 10, so basically the received label along with prefix will always become outgoing label. What will you call it? Outgoing label, and it will become now 10 for it. Now remember that labels have locally significant, I mean they are always locally significant. Whenever a router will receive any label for any prefix from its neighbor device, then next time, I mean then now it will generate its own label as well for that prefix. So let's say that R2 have generated its local label for this prefix is what? 20. And then exit interface will also be specified over there immediately. Exit interface is what? S0 by 0 on R2. Hello. In terms of data, this is in terms of data, not in terms of prefix actually, because it received a prefix onto S0 by 0. So this interface will become now outgoing interface, but for what? Data, not for prefix, because for prefix it is incoming interface because it received this prefix onto this interface, right? But in respective of data, this interface will be known as outgoing interface. And in same manner, we received label number 10 for this prefix onto this interface, so it should be incoming interface, right? But in perspective of data, in terms of data, this label will be known as outgoing label. Then R2 will inform to its neighbor router R3 that if he wants to reach 10.1.0/24, your outgoing label is going to be, tell me, outgoing label will be now 20, and then let's say local label is now 30, and then outgoing interface is what, S0/0, and next hop will be whatever it is, right? Have you got it now? Like 23.1.1.2. Then R3 will inform to its neighbor R4, and this time it has generated local label as 30. So now it will ask to R4 that if you wanna reach 10.1.0/24, then your outgoing label is going to be 30. Let's say local label is now
40.
fine, and then outgoing interface is fine.
So based on what they will generate, that we have to use automatically with the.
Of course, automatically. And they can generate same labels as well. It is not always necessary that routers will always generate different labels, no. Like R2 could also generate 10 itself, then it will advertise 10 towards R3. So for R3 its outgoing label will also be 10. You understand? There are two things actually. One is like upstream router, and one is known as downstream router. In MPLS there are two terminologies, upstream and downstream. Downstream is always near to prefix originator, near to prefix originator, which will be always known as downstream router, and upstream router which is far from the originator. So for R2 downstream is R1, upstream is what, R3. So label will always be advertised towards upstream. However, it will also advertise that to the downstream, but downstream will not accept that label. Right? So for R3 its downstream is R2, whereas upstream is what? R4. It is differently from STP. In STP the upstream was from near to root bridge. Downstream was, right? Here it's different. Downstream near to prefix originator. Upstream far away from the prefix originator. You understand?
Is the level generated per prefix generated?
Per prefix generator. Every time it will be generated by MPLS per prefix. Like if you are having 100 prefixes, then for all 100 prefixes there will be a separate label. Remember, one router cannot generate same label for two different prefixes. But yes, it is possible that two different routers can generate. Fine. Now let's say there is a host connected to R4. This host wants to send data towards .1.1. So this host will send this data towards R4 without any label, because PC do not understand any label. It does not understand MPLS, right? So this time R4 received unlabeled packet. Unlabeled packet. And what I told you, if any router receives unlabeled packet, it will perform lookup in its SAP, in its fib. So there are, see, on every router there will be two things. One is fib and another one is what? Lfib. Here also it will be fib as well as Lfib. Here also it will be fib as well as Lfib. Here it will be fib as well as LFIB on all routers, right? So what is the rule actually? That if you received unlabeled packet, then you will always perform lookup in your FIB. So of course it will be having this prefix information in FIB, and also its outgoing label will be 30 inside FIB as well. I mean, this information will also be available in FIB. So now R4 will perform lookup in its FIB. We'll come to know that it needs to transmit this packet out from S0 by 0. Right? So R4 will transmit packet out from S0 by 0 now with label, because its outgoing label is what? 30, and this information will be existing in its SAP table as well. I mean, as I said, that FIB will also contain your label information, right? So now R4 will send this packet with label number 30. Fine. What I taught you, if a router receives a labeled packet, it will perform lookup in its LFIB. Now this is your LFIB. So what does it mean? That if any packet comes with label 30, outgoing label will become now 20. Means that this label 30 will be replaced with label 20, and its outgoing interface will be, it will not require to open its IP header. Check it out. Does it require to open its IP header now? It received. See, this entry will be there in its LFIB, that if it receives anything, any packet with the label number 30, then it has to replace it with the label number 20, and it has to send it out from S0 by 0. This mapping is already there. So this time this R3 is performing swapping. See, there are some other terminologies as well, like label imposition, or you can also say push, right? So the meaning of label imposition or push, you can also remove your label, hey, removal of label, or you can also call it popping. You can also call it pop, because the meaning by pop is also remove. And there is one other terminology also exists, which is what? Swapping. So remember, swapping will always be done by P routers, whereas imposition and deposition, I mean popping, will be done by HLSRs. Because whenever a packet will come from non-MPLS domain, will get entered into MPLS domain, then HLSR has to impose label onto your packet. Just like here we saw that on R4, it imposed, R4 imposed label number 30, whereas R3 is performing simply swapping. It received packet with label number 30, it has swapped with 20, and it has sent it out from S0 by 0 now, because it knows very well that outgoing interface is what. Have you understood it or not? Then R3 will send this packet towards R2, out from S0 by 0 with label number 20. So if R2 receives any packet with label number 20 here, outgoing label is what? 10, and outgoing interface is what? S0 by 0. We'll send this packet without opening IP header out from S0 by 0 with label number 10. Now remember that router do not contain directly connected prefixes in its LFIB. Router will never insert directly connected prefixes in its own LFIB. There is a rule in MPLS that for directly connected prefixes, routers will never enter directly connected prefixes in their LFIB. So now whenever R1 will receive this packet coming with label number 10, so because this is labeled packet, so first of all it will perform lookup in its LFIB. This is LFIB, right? But it will not get that entry in its LFIB. And remember that if router performs lookup in its LFIB and if it does not get anything over there, then it will perform lookup in its FIB and will open its IP header as well. So this time it has to perform recursive lookup. It has to perform recursive lookup. Have you understood it? Understood or not? There is a rule. If you receive labeled packet, then first of all you will perform lookup in your LFIB, right? I mean, you will always perform lookup in your LFIB. If you receive unlabeled packet, you will perform lookup in your FIB. Fine. Now thing is, like in MPLS there is one another rule also exists, like for directly connected prefixes will never get enter in your LFIB. Directly connected prefixes will never get enter in your LFIB. They will get enter in your FIB only. Now thing is, like when R1 have received this packet with label number 10, because it was labeled packet, so it has to perform lookup in its LFIB first, but it will not get that entry available in your LFIB, then it has to perform lookup in its FIB. So that is called recursive lookup. So edge devices will require to perform recursive lookup, and of course it can cause a problem. I mean, of course it is causing problem because your device has to perform recursive lookup. So to solve this problem, we are also having another concept in MPLS, which is known as PHP, penultimate hop popping. So I will teach you this meaning of PHP as well. We have solved it. Nowadays this problem do not exist onto your devices because we are using PHP, and PHP is by default enabled in MPLS. I will teach you that what is the meaning by PHP. So basically with the help of PHP, they have fixed this problem of recursive lookups.
What is the abbreviation of PHP?
Penultimate hop popping. Penultimate hop popping. Popping before one hop. That's the meaning by penultimate, before one hop. Prefix your label, outgoing label, local label. This is the entry of LFIB. Outgoing interface, next hop address. Please.
FIB may be same method.
What?
FIB.
FIB may be same रहता है. FIB will also contain the same information, but the problem is FIB do not contain local label. FIB contains only and only outgoing label, whereas LFIB will also contain local label. So basically FIB cannot perform label swapping. FIB cannot perform label swapping. Label swapping can be performed by LFIB only. With the help of FIB, you can perform imposition of label, nothing else. Fine guys, so basically MPLS will switch your data in this manner, right? In same manner, let's say that R4 is also having its own lane network, let's say 40.1.1.0. It will also advertise that prefix towards R3 with the label number. Then R3 will also advertise it towards R2 with the label number. R2 will also generate its own label number and will advertise that towards R1. Then in same manner traffic will come back from there to here.
सर एलफिब सिर्फ लोकल लेवल ही रखता है.
No, Alfib, see these are the components of Alfib. You see, this is your Alfib. Prefix, outgoing label, local label, outgoing interface, and next hop address. Whereas FIB contains prefix, outgoing label, outgoing interface, and next hop address. But FIB do not contain local label. That is why I am saying that FIB cannot perform swapping. Here you can swap it because whenever a packet will receive with local label, it will swap it with its outgoing label. But remember, very simple rule is there. If you receive unlabeled packet, you will always perform lookup in your fib. If you receive any labeled packet, you will always perform lookup in your alfib. Now let's talk about these labels now, and then after I will also teach you PHP as well, right? So I hope that you people have understood the meaning by imposition and deposition. Imposition of label: whenever a packet will get entered into MPLS domain, then HLSR will be responsible to impose a label onto your packet. And whenever your packet will leave your MPLS domain and will go towards non-MPLS domain, then HLSR will again be responsible to pop, to deposition your label, right? To remove, to pop your label from outgoing packets. See, what is that? As I said earlier on, that label will always be 4 bytes long ID. I mean, it will always contain 4 bytes in one label. Define the destination and services for a packet. What is the meaning by services? Like here, like inside IP header, we were having TOS. We were having type of service, right? Here in MPLS also, we are having 3 bits as experimental bits. Here we will be calling them as a experimental bits, and those experimental bits can define your service of packet. I mean, kind of quality of service. Label also identify your FAQ, forwarding equivalence class. Now you will be confused. What is the meaning by FAQ? Forwarding equivalence class. A group of all those packets which are forwarded over the same path in a same manner. A group of all those packets which are forwarded over the same path in a same manner is known as one FAQ. One label belongs to one FAQ. One label, you can also say, that's why here they have defined it, identify FAQ, because one label will be responsible to identify your FAQ. As you can see here, that whenever R3 will receive any packet with the label number 30, it will always switch it out from S0 by 0 with the label number 20. So all those packets which are coming with the label number 30 will be switched out from S0 by 0 with the label number 20. So all those packets, a group of all those packets which are coming with the label number 30 will be known as one FAQ, forwarding equivalence class, because all those packets which are coming with the label number 30 will be forwarded out from S0 by 0 with the label number 20. Have you understood it or not? FAQ, forwarding equivalence class. Again, I'm repeating my lines. A group of packets which are forwarded over the same path in same manner. So of course, for a single prefix you are having a particular label. So for that prefix especially, all packets will follow same path. So all those packets will be known as now one FAQ. And this path which is followed by your packet for your prefix will be known as LSP, labeled switch path. A path which is followed by your packet, hello, in your MPLS domain will be known as LSP, labeled switch path. Again, try to get it. You are having MPLS domain right now. I just connected in a serial way all these routers. Might be that you are having zigzag topology. Some routers are there, all are connected to each other, something like that, right? I mean, some routers are connected to each other. I mean, you are having multiple paths, right? But finally there will be only one best path. So a path which is followed by your labeled packet to reach your destination will be known as LSP, labeled switch path. And LSP will always be unidirectional. Might be you are using asymmetric routing, because if you are using asymmetric routing, then might be that outgoing path will be different from incoming path, right? That is why LSP is always LSP will always be LSP is always unidirectional actually. Unidirectional, like if packets are going from one end to another end, that will be counted one LSP. If packets are coming back from there to here, that will be known as another LSP, because as you know, for each prefix there will be a different label. Try to get it now. See, have you understood the meaning by imposition, deposition? I mean, like popping the label, switching the label, right? Have you understood the meaning by FAQ, forwarding equivalence class? A group of packets which are forwarded over the same path in a same manner is known as FAQ. LSP, labeled switch path. A path followed by your packet will be known as LSP. And of course, if packets are going from R4 to R1, it will be known as one LSP. But if packets are coming back from R1 to R4, might be that they can go through, they can come via another path as well, right? So it will be known as another LSP, label switch path. Fine, guys. Let's talk about this label once again. Each LSR independently maps a label to an FAQ in a label binding. See, each LSR independently maps a label to an FAQ. Here, they are denoting this FAQ to one prefix. Here, they are calling this FAQ as a one prefix, because there is a rule that for each prefix, they will map a unique label, as I said. So basically one FAQ, of course, as I said, one prefix, one label, one FAQ. Because one label also denotes one FAQ, and one label will denote your one prefix.
A local router पे होगा ये same.
Not on local router. I mean, yeah, you can say like that. Now label bindings are exchanged between LSRs, label switch routers. So to exchange that label information, there will be some, I mean, we will require to have some protocols which are either TDP or LDP. TDP is Stack Distribution Protocol, which is Cisco proprietary, and it was used during tag switching. But nowadays we are using MPLS, that is why we will use LDP only, Label Distribution Protocol, which is an open standard protocol. Now you see, an MPLS label is a 4-byte fixed length locally significant identifier that is used by network core devices to make forwarding decision for a packet. Labels define the destination and services for each packet and identify a forwarding equivalence class. The label put on a particular packet represents the FAQ to which the packet is assigned. Labels have local significance to a label switch router. Each LSR is a network in the network makes an independent local decision regarding which label value to use to represent an FAQ. I mean, to represent your prefix, right? Fine. FAQ is a group of packets forwarded in the same manner over the same path with the same. Have you understood it now? This is your label format. 4 bytes. As I said that your label will always be 4 bytes long label. So in these 4 bytes you are having this information. First 20 bits will be responsible to represent your label number. First 20 bits will be responsible to represent your label number. That is why the range of labels can be from 0 to 2 raised to the power 20. You can calculate it by yourself. It will be like 100,000 something. Yes. Then next 3 bits are known as experimental bits, which will be used for traffic, I mean quality of service actually, which will be used in quality of service. This is like IP precedence values inside IP header. These experimental bits are same as IP precedence values in IP header. Like for TOS, we were having 8 bits. Out from those 8 bits, 3 bits were reserved for IP precedence. In same manner over here, we are having 3 bits for experimental. I mean 3 bits as experimental bits, and these 3 bits will be used for quality of service only. Next bit, this is 1 bit only, and this is known as S bit. S bit means bottom of stack bit. Bottom of stack bit. As I said, you can have multiple labels in between layer 2 and layer 3 header. You can also have multiple labels. How label will come to know that after this label there is no other label exists before IP header. This is the last label before IP header. Now it has to hand over this data to the IP itself. How will it come to know? For that purpose here, this is S bit. If this S bit is 1, it means now it is having IP header. After that it does not have any other label. If this S bit is 0, it means it is also having some other labels in it, and that is why here we will be calling it as label stack. Label stack, more than one label. What is the meaning by label stack? Means it is having more than one label. So basically there will be a label stack in between layer 2 and layer 3 header, so it can also have more than one label as well at same time, right? So if it open, like there will be multiple labels like outer label, inner labels, outer label, inner labels. So first of all, routers, devices will open only and only outer label. Like you, with using GRE tunnel, you can add more than one IP header over your packet, right? So only outer IP header, external IP header was opened by the devices. In same manner over here also, if you are having more than one label in a label stack, then only outer label will be opened by your network devices. So how will it come to know that it is also having some other labels as well in its label stack? For that purpose here it is using S bit. If it is 0, it means it is also having one more label. If it is 1, it means it does, it will not specify it is also having one more label. No, it can also have more than one label, it can also have more than two labels as well, right? But it means that it is not going to hand over this packet to the IP now. Still it is having some more labels. As you can see, 3 bits experimental bits typically used to carry IP precedence value. 1 bit bottom of stack indicator indicates whether this is the last label before the IP header. 8 bits TTL, same as IP header, and to prevent your network from indefinite loops. Otherwise packet will always be there if there is a loop, right? But if TTL value is there, then you know very well that whenever a packet will traverse one router, TTL value will be decremented by 1. Once it will get 0, your packet will be discarded automatically. See, bottom of stack bit. MPLS allows multiple labels to be inserted. This bit determines if this label is the last label in the packet. If this bit is 1, it indicates that this is the last label, and if it is 0, it means it is not a last label. Now there are 2 modes of MPLS. Actually, one is known as frame mode, one is known as cell mode. Frame mode is normal MPLS cell mode over ATM. Hello. If your layer 2 technology is ATM, then you have to configure cell mode MPLS. So here we do not have an ATM, so we have to configure only and only frame mode MPLS. Frame mode MPLS means over Ethernet, over SDLC, PPP, frame relay, right? And see MPLS label insertion, frame mode MPLS. This is frame mode MPLS. You are having layer 2 header. It can be either SDLC, PPP, or Ethernet or frame relay, and then layer 3 header. Then once, because this time this router received this packet came from non-MPLS domain. Now this packet is getting entered into MPLS domain. So now it will add MPLS label in between layer 2 and layer 3 header, and which is also known as shim header, And for MPLS, Ethernet's type field will also get changed, because this time Ethernet will not hand over it directly to IP. This time it has to hand over it to the MPLS, so that its protocol ID will also get changed. And that will be I think 086 something like that. I don't remember exactly. 0847 0x8847 in case of MPLS. Whereas in case of IPv4 it is simple 0x0800. So this protocol ID will also get, protocol type will also get changed inside the type field of layer 2 header. Now what is an MPLS label stack? As I said, usually only one label is assigned to a packet, but multiple labels in a label stack are supported. So if you have configured MPLS VPN, layer 3 VPN, then there will be at least 2 labels in your label stack. If you have configured MPLS traffic engineering, then again there will be at least 2 or more labels. And if you have configured a VPN with traffic engineering, at least 3 labels will be there, 3 or more. Understood? Should I tell you once again it? As I said that in a label stack you can have more than one label as well. However, MPLS will allocate only one label, but it will be depending on your services, that what type of service you are using in MPLS. Like if you have configured VPN, then there will be at least 2 labels. If you are using traffic engineering, then again there will be at least 2 labels. But if you are using VPN along with traffic engineering, then at least 3 labels will be there in your label stack. Like this. So remember, this will be your sequence. Like if you have configured VPN along with traffic engineering, then there will be at least 3 labels, right? So outer label means top label will always be traffic engineering label, because traffic engineering label will define that which path it has to follow. And then LDP label will define that what is its next hop. What is its next hop? So it will be known as inner label, and finally there will be a VPN label. So in this sequence, and remember that whenever a router will receive this packet, first of all it will open only traffic engineering label, which is outer label, and then finally it will open LDP label, and then finally it will open VPN label, right? So in this sequence, these labels will get inserted in between layer 2 and the layer 3 header. So if you are using traffic engineering, VPN, LDP, everything, then first of all traffic engineering label, then LDP label, and then finally VPN label. If you are using only and only VPN, then first of all LDP label will be known as outer label, and then VPN label will be known as inner label. This is your, see, top, middle, bottom. So bottom label will always be having its S bit as 1. Bottom label will always be having its S bit as 1. Whereas top and middle labels will always be having their S bit as 0. You see. So inside layer 2 header type field is having 8847. 8847. I think it is visible to you. No? Now it should be visible. 8847. And last, bottom label is having its S bit as 1, because then after it does not have any other label. The receiving router uses the top label only. It is something like you are receiving a packet with multiple IP header, but it will open only and only outer IP header. So unlabeled IP packet, as you know very well, 0800, labeled unicast 8847, as we have seen. Labeled multicast, if you are received one multicast packet and it is labeled, then it will be 8848. See, what are MPLS label operations? LSR can perform insertion, which is also known as imposition or push. Swapping, it will be done by LSR only. Remove, pop, will be done by as LSR.
Insertion with LSR के
What?
As LSR के वही करेगा ना?
Insertion, yes, that's what they said. On ingress as LSR. Ingress, where packet is getting inserted, right? And removal will be done by egress as LSR. I have already taught you all these things. See, pop, next hop. See, here it is performing lookup in its LFIB as well as IP lookup. FIB is not it. So it is performing recursive lookup. You see. Done. Now take break and we'll continue. Case. So now thing is, we have came to know that MPLS, how MPLS is going to do work, and we have also came to know that there is a problem of recursive lookup. There is a problem of recursive lookup. So to solve this problem of recursive lookup, there is a concept of PHP, penultimate hop popping. So actually what happens, as I said, that your labels from 0 to 15 are reserved. Fine. So if any router is having its directly connected prefix, for its directly connected prefix, it will never generate any label out from this reserved range. It will generate implicit null. Implicit null. Let me show you. I will specify it. So whenever it will advertise this 10th prefix towards its neighbor, previously it was advertising that label with label number 10, but this time it will advertise it with label number implicit null. Let me show you. Implicit null, and actually it is not implicit null, it is label number 3. It is label number 3, which comes from reserved range 0 to 15, but it will never show you label number 3. It will always show you only and only implicit null. So whenever this R1 will advertise this prefix 10.1.0 towards R2, its outgoing label will become now implicit null, and which means pop. Which means pop. Let me show you. Let me specify it once. Here, because it received this label, it received this prefix from R1 onto S0 by 0 with the label number implicit null. So its outgoing label will become now pop. Its outgoing label will become now pop, because the meaning by implicit null is what? Pop. Fine. Now, if packet is transmitted by this host, it will give it to R4. R4 will perform lookup in its fib only. It will come to know that outgoing label is 30 and outgoing interface is S0 by 0. Will send this packet with label number 30. R3 will receive it with the label number 30. Will swap it with 20. Will send it out from S0 by 0. Will give it to R2. R2 will receive it on S0 by 1 with label number 20, and 20 will be swapped with pop. 20 will be swapped with pop. And what is the meaning by pop? Just remove label. So this time R2 will send this packet without any label, because it has been popped by R2 itself. So whenever R1 will receive this packet, it will receive unlabeled packet. It will receive unlabeled packet. And what I told you, that if any router receives unlabeled packet, it will perform lookup in its FIB only, not in LFIB. So this time R1 will directly perform lookup in its FIB only, not in LFIB. Have you understood it or not? So this is the meaning by penultimate hop popping. So what is the meaning by penultimate hop popping? That you are performing popping before one hop. You are performing popping before one hop. That is the meaning by penultimate. Penultimate hop popping. Have you understood it or not? Hey, just try to understand. For directly connected prefixes, previously in previous example I told you that okay, it will generate label number 10. No, never. For directly connected prefixes, MPLS will always generate its label as implicit null. So whenever it will advertise that directly connected prefix towards its neighbor, it will go with implicit null. So this, for this router, for neighbor devices, outgoing label will be implicit null, which means pop. So this PHP is by default enabled. Fine. Now, as I said, that to exchange label information between two routers, there must be some protocol. There must be some protocol. So we are having two protocols over here to distribute your label information between two routers. One is TDP, another one is what? LDP. TDP is a Cisco proprietary. So we will not learn anything related to a TDP, but we will go through LDP, label distribution protocol. Same as like you are having EIGRP, RIP, BGP and OSPF to exchange route information, and to exchange label information you will be using either TDP or LDP. And TDP and LDP will be working in control plane. Control plane will be responsible to control your LDP or TDP. And with the help of that, they will form LIP, label information base, and then finally LIP will get copied back into LFIB. So now we are going to learn about it. Label assignment and distribution. You see, we will be talking about LDP only, label distribution protocol. However, apart from that, you are also having TDP. You see, LDP, and apart from that, you are also having TDP. Now, how LDP works actually? How LDP works. The very first thing that LDP uses TCP port number 646. It's same as BGP. Like BGP was also using TCP port number 179. Here
646.
exactly 646. TDP was using TCP port number 711. Now LDP uses UDP as well as TCP, both of them, and port number will remain same whether it is using UDP or TCP. Because there are two things. One, LDP will send hello messages to discover its neighbor and to maintain neighborship. Second, LDP will also exchange label information. It will also give an update to its neighbor router, right? So hellos will be forwarded with the help of UDP, and then after, label binding information will be exchanged over TCP connection. So hellos will always use UDP. After that, everything else will be forwarded over TCP connection. And for both of them, whether it is using TCP or UDP, it will be using same port number, which is 646. As you can see, LDP establishes a session into two steps. Hello messages are periodically sent on all MPLS enabled interfaces. Well, once you will enable MPLS onto any interface, it will start to send LDP hello messages. Because by default in MPLS, LDP will be enabled, not TDP. MPLS enabled routers respond to a received hello message by attempting to establish a session with the source of the hello message. LDP link hello message is UDP packet sent to all routers on the subnet, which is 224.0.0.2. Means LDP will multicast its hello messages by default. But then after, because it has to form TCP session, so TCP session will be unicasted. Hello, to form TCP session, you cannot send your packet as with using multicast address. No, because TCP session means you are forming end-to-end connection. So TCP is used to establish the session. Both TCP and UDP use well-known port number 646. What are LDP hello messages? Hello messages are sent to all routers reachable through an interfaces. LDP uses well-known port number 646 with UDP for hello messages. It will be having 6-byte LDP identifier, in which 4 bytes will be used to define your router ID. Remaining 2 bytes will be used for label space. The source address used for an LDP session can be set by adding the transport address TLV to the hello messages. Forget about that. Here they are talking about the contents of hello packet. So hello basically will be having its router ID, as well as I will discuss it, don't worry. I will open this LDP packet and then I will show you that okay, which kind of information is contained by hello packet. Fine guys, so they have also mentioned over here that hello packets, in LDP, hello packets will always use UDP 646, and then after they will form TCP session. As you can see over here, see LDP neighborship, see they are sending hellos to each other with using UDP port number 646 and multicast address 224.0.0.2, and then after they are forming TCP session, and TCP session will always use unicast address. It will never use any multicast address. And one more thing I would like to tell you over here in LDP, which is really important for you to understand. In LDP, there is again LDP router ID, right? In LDP also you are having router ID, and the procedure of allocating router ID is same as OSPF and BGP. But here in LDP, router ID must be reachable. If router ID is not reachable, router ID must be any IP address which is configured onto any interface. You cannot use any router ID over here, right? However, you can modify it, you can configure it statically, but you cannot say like router ID 1111. No, you have to call your interface only. You have to call your interface only. In LDP, it is mandatory that your router ID must be reachable. Must be reachable. Of course, it must be configured onto any interface, because under router ID you can call only and only interface. You cannot directly allocate ID. But here it must be reachable. If router ID is not reachable, LDP peering will not come up. Will never come up. And this is the, I mean, most of the time you will get this type of problem in MPLS, that we do not care about this LDP router ID. Let's say that it picked highest loopback, and that loopback was not advertised into your routing protocol, so that loopback will not be reachable from the neighbor device. Now they cannot form LDP neighborship. So remember that in LDP it is mandatory that their router IDs must be reachable. Fine. Are you okay with it? Great. Now after it, in LDP, if you are having more than one connections in between two devices, like 2, 3, and you have enabled LDP onto all interfaces between these two routers, right? But still, remember, there will be only one LDP session. Between two devices, you can have maximum one LDP session. Doesn't matter that how many links are existing over there. Like in case of OSPF, there will be multiple neighborship. In case of EICRP, there will be multiple neighborship. But in case of LDP, there will be only and only one neighborship, because there can be only one LDP router ID onto both routers, and it will form neighborship with using your LDP router ID, and it can be common. It doesn't belong to your link actually. It belongs to your device. So remember, in LDP, if you are having more than one connections in between two devices, then also there will be only one peering. Understood? So you have to remember all these things. That's what they have explained over here now. LDP neighbor discovery and all these things. So now after sending hello packets, they will establish TCP session. Then after configuring TCP session, they will send initialization message to each other. Once you will get the keep alive in the response of initialization message, it means now they can send binding information to each other. They can give an update to each other. Peers first exchange initialization messages. The session is ready to exchange label mappings after receiving the first keep alive. So first of all, they will discover their neighbors by sending hello packets. Then they will form TCP session. After formation of TCP session, they will be responsible to send initialization messages, and then they have to send keep alive. Once you will receive keep alive, now you can advertise your binding, label binding to your neighbor. You can exchange now label information with each other, right?
So multiple neighborship वाला समझ नहीं.
What I said, there will not be multiple neighbors. Like if you are having multiple links in between two routers, if you have enabled OSPF on all those links, how many neighbors will be there? But in LDP, keep alive interval will still be 60 seconds and hold down timer will be 180 seconds. Same as BGP. But hello interval is 5 seconds and hold down interval is I think 15 seconds. Let me show you. I will prove it actually, but what I remember that hello interval is here 5 seconds. It's not there, but I'll show you, right? In LDP, you can also configure static neighbor. If you configure your neighbor statically, then your hellos will also be unicasted. I mean, you can also form indirect neighborship for LDP, same as BGP. Where will you use your targeted LDP sessions? Means where will you configure static LDP sessions. In which conditions you will require to configure that? If you are going to configure fast reroute FRR in MPLS, or MPLS non-stop forwarding, or MPLS LDP session protection. If you are going to use any one of the feature out from these three features, then you will require to configure targeted LDP sessions. I'll teach you that how can you configure targeted LDP sessions. But remember, if you have configured targeted LDP session, it will always unicast even hello messages as well. Previously it was unicasting only TCP based packets, but now
Plus also.
yes, hellos will also be unicasted. So summary: UDP multicast is used to discover adjacent LDP neighbor, while TCP is used to establish a session. LDP hello messages contain an identifier field that uniquely identifies the neighbor and the label space. I mean, they are talking about the LDP router ID. Per platform label space require only one LDP session. See, per platform there will be only one LDP session, right? And LDP session is initiated in TCP from the higher IP address router. Higher IP address router, or you can say a router which is having higher router ID will always initialize your TCP session in LDP. So in exam, if they ask you that okay, this router should always initialize this TCP session, then that router must have higher router ID. LDP session negotiation is in a three-step process: establishing the TCP session, then exchanging initialization message, and finally keep alive. Non-adjacent neighbor discovery is accomplished by using unicast IP address instead of multicast. As I said that you can also configure targeted neighbor, means that static neighbors. Fine. Now it's time to implement LDP. I mean, the only thing which is now left in LDP is practicals of LDP, right? So to perform practicals of LDP, it is very simple over here. I'll take only 3 routers, or 4. What do you say? Okay, let's take 4 routers.
Zero by series, sir.
My God. Sorry. Each router will also be having yes. he wants to enable MPLS, go to FA0/0, say MPLS IP. That's it. We wanted to enable MPLS onto this interface. We have enabled it. To see that, show MPLS interfaces. What is running? Now move on. Go to FA0/0, say MPLS IP. Show MPLS. What is running? Have they formed neighborship? No, they will never form. You know why? R1 will elect its router ID as 1111, and on R2, because we configured loopback address, it will configure its router ID as 2222 automatically. But they are not reachable to each other.
How do we see the routing?
On R1, show MPLS LDP. Sorry, not neighbor. LDP in even it is showing us that no route. However, they will keep on to send hello messages to each other. You can see that. In every 5 seconds. It's not it. Hellos are going in every 5 seconds, and they are multicasted. 12.1.1 is giving there. See, UDP is not it. Hello message is also containing your transport address, which is 11. This is the router ID actually. So this transport address must be reachable. Understood? Now move on. R1. Say router ICRP 100 not or somebody network. Move on R2 as well. Now see, ICRP neighborship will come up, but along with that, LDP peering will also come up. It's not it, Sardeep. Hellos are coming from 12.1.1, but actually TCP session was formed with using IP addresses 1111 and 22222 because they have been configured, they have been elected as their transport addresses. So it was initialized by SYN message was generated by R2 first because it was having higher router ID or this transport ID, and router ID will always be your router. You understand? Understood? Fine. In this way, they will form LDP peering. Now on R2 itself, go to FA0/1, say MPLS IP. Then go to R3. Go to R4, but they will not form. Yes. Now they will form LDP peering as well as how. Okay, it means I have not configured IP addresses onto R3 yet. Oh, sorry.
23.1.1.
Yes. sorry, FA0 by 0. LDB pairing have also came. Fine. Now, see, as I said that for self-advertised, like R1 is having this 111 as directly connected, so it should generate its label as implicit null. To see that, show MPLS LDP binding. For 111, its local binding is what? Tell me, it has generated what? Implicit null. Now it will advertise it towards R2. Show MPLS LDP binding. So it will receive remote binding given by 111 is what? And this is what? Downstream router. So it has to, its outgoing label must be that label which is given by downstream router. So downstream is what? 1111. So now you do one thing, show MPLS forwarding table. This is your LFIB. So to reach 1111, outgoing label is what? Tell me, pop tag. Because it received this prefix from R1 with implicit null. Now it have generated its label as 16. So it will advertise it towards R3 with the label number 16. As you move on R3 and now say show MPLS forwarding table. You see, for 1111, its outgoing label is what? 16, which is received from R2, and it has generated what? 18. So it will advertise now 18 towards R4. So show MPLS forwarding table. You check it out that for 1111, outgoing label is what? 18, whereas local label is what? 20. So you can see that labels have been allocated from 16. They have started to allocate labels to each prefix from 16 only. From 0 to 15, all are reserved. Understood? This is LP, so MPLS forwarding table. And if you want to see SAP, see all those components are available which I explained to you. Show IP SAP 1.1.1. It is having only and only outgoing label 18. And what I told you, that SAP will be having only and only outgoing label, not local label. Fine.
फिर नीचे करना है local tag
In post tag 18 outgoing label. So whenever packet will go towards this prefix, it will impose. If it receives any untagged packet which is going towards this prefix, right? So in this way we will be doing this configuration. So rest of the configuration will perform tomorrow. Now we have seen that how are they exchanging their label information, right? So all routers are generating their on label. That's why I said that labels have their local significance.